Hello there, you beautiful people. We now know a lot of stuff in Python. As well as knowing about variables and if statements for creating logic, you also know how to use strings, integers, floats, and Boolean data types, which is awesome. These are the building blocks of a lot of Python programs, and you should be super proud of yourself for making it this far. You've really learned a lot, and I'm very proud of you. So sometimes, believe it or not, it's actually inconvenient and inefficient to have these little pieces of data floating around, each with their own variable name. Python data structures make it possible to group massive amounts of data together and store them all under one variable name. Now, data structures make it possible to operate on thousands or even millions of pieces of data all at once in a single line of code. Crazy, right? So Python gives us a variety of data structures that we can use, including lists, tuples, and dictionaries. And in this section, we're going to teach you all about all three of them. We're going to cover what they are, how to make them, and some cool stuff that you can do with them. You're going to be building two projects in this section, which is quite cool, right? So first of all, you're going to build Travis, the ridiculous security system. Travis will have a list of known users in his security database, and he will be able to detect an intruder. However, Travis is ever so polite, so whenever he finds an intruder, he's just going to ask them if they want to be added to the list. This project will teach you all about combining logic with your Python data structures, which is an incredibly powerful ability, so you'll want to watch out for that. You're also going to be building a cinema booking simulator. The cinema is going to have a list of films with their appropriate age ratings and the amount of seats left. When a user comes to buy a ticket, the computer will ask for their age and check if there are enough tickets left before allowing the user to buy a ticket. Nice, right? So by the end of this section of the course, you're going to know about Python's data structures, how to make them, how to use them, and in what circumstances each type of data structure works best. So in the next lecture, we're going to jump in and discover the first and most common type of Python data structure, which are lists. So I'll see you in the next video. Hello there, you beautiful people, and welcome to this lecture about the most common of all Python data structures, lists. So in this lecture, you're going to learn what lists are, how to create them, and some things that you can use them for. We're also going to see how to add things to a list, how to get data from a list, and also how to slice a list into little useful pieces. So in the process, you're also going to learn how to create tables and matrices in Python, and you will also be introduced to Python's very useful in keyword, and you're also going to learn how to combine lists with logic. So let's get cracking. Okay, so first things first, how do we create a list? Well, we create a list by using square angle brackets. So let's say we had a variable called our list, and we set that equal to a list with 5 numbers in it. We would type our list equals, then open a pair of square brackets, and in here I'm just going to put 5 numbers with commas in between them. So let's say we've got 27, 46, minus 5, 17, and 99. Okay, now when I press enter, that's gone and saved itself in there. Now when I print our list, we're going to see that we had 5 numbers printed to the screen rather than just 1, which, before when we use normal variables, you could only just get 1 value out. So that's pretty nice and easy, right? And if we use the type function, just to show it to you, type of our list, it's going to tell us that it's a list. Nice and straightforward. Now, a really cool thing about Python lists, unlike those in other languages, is that Python lists can have multiple data types inside them. For example, you can have a list that contains numbers, strings, and Booleans. So for example, if I create a list called Jackson, and I set that equal to, inside here, A, B, C, 1, 2, 3, do, oops, I need a comma, do, re, mi, true, and false. Okay, so if I do that, that's all going to work fine, and that's totally valid code, and most of it is also a musical classic, which is a nice bonus. Now, lists in Python are an iterable data type, just like strings are. Now, if you remember from our previous discussion on strings, and if a data type is iterable, that means it can be broken up into little pieces called elements. And each element has its own index, which start at 0 and they count up from there to allow you to access the element. So for example, the letter A inside Jackson here would have index 0, this would be index 1, this would be index 2, and so on. So 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so how can I access a specific element? Well, the way that I can do it, let's say I wanted to just get the number 2 from here, right? That's 1, 2, 3, 4. Oh, sorry, 0, 1, 2, 3, 4, index 4. So the way that I'd type it is I'd say Jackson, open up some square brackets, and type the index in there. Now when I press enter, we're going to get back 2 because number 2 is at index 4. What if I wanted to get Ray? Well, this is index 4, index 5, index 6, index 7 should be Ray, the string. So Jackson of 7, and we're going to get that out. And you don't have to count all the way from the start like we discussed before. You can count back from the end. So let's say if I wanted this, the element at the very end has index -1, and this one would have -2, -3, -4, -5, and so on. So let's say if we wanted true, what we'd have to type is Jackson of -2, and if I press enter, that's going to give us true. So that's how you can get certain elements from a list. Now you can save these elements in variables as well. So let's say if I wanted to get just dough, I could say x equals Jackson of 0, 1, 2, 3, 4, 5, 6, 7. And, oh no, not 7, 6. And what that's going to do is it's going to hopefully save in there dough. So you can see you can take little pieces out like that. So what if you wanted to take out more than one element? Well, for this you need a slice. We've discussed slices previously in the section on strings, so go back and have a look at those lectures for more information, but I'm just going to give you the basics of how it works. So let's say we wanted to take out from Jackson A, B, C, right, into its own little list. Well, the way that we do that is we would basically say Jackson, open up some square brackets, just like we were doing for one element, and you tell it where you want to start, then a colon, where you want to go up to, but not include, so I'm going to call that end, you don't include that one, and then the step, okay? The amount of steps you want to take in between each item, which defaults to 1. So let's say we want ABC. We want to go from index 0, because that's A. We want to go up to the 1, but not including it, which is going to be index 0, 1, 2, 3. Okay, and if we don't do anything, that Python's just going to assume the step is 1. So let's just do that. And you're going to see we get ABC as its own slice of the list. Now, if we look at Jackson, the original data, you're going to see that that hasn't been changed. And the reason for that is slices just take a copy of the original information. They don't replace it at all. If I did want to replace it, I would have to overwrite the list in some way. Now, this is where lists get interesting. Lists can have other lists inside of themselves. That's right. We're working with list-ception. Okay. So, for example, let's say we had a list called. Let's just overwrite our list and set it equal to 1, 2. Then we put another list inside, which was 3, 4, 5. Then we had 6, 7, and 8. Okay, so you can see we've got a big list here, and then inside of it we've got another list. So let's save that. That works fine. So how can we get this big list from in here? Well, it works pretty much in exactly the same way. So this is index 0. This is index 1. This whole list is index 2. So if I show you that, our list, index 2, we get a whole list out. But what if I wanted to get the number 3? Just the number 3. Well, the way that I do that is what I would do. Okay, so you agree that this gives us this list. Okay, what index in this little list is the number 3? It's index 0, right? Because this is index 0, index 1, index 2 of the small list. So we just put another little bracket here and we say we want index 0, and that's going to give us out 3. So we want index 0 of the second index of the big list. The second index of the big list is 345, and index 0 of 345 is 3. Likewise, if I had index 1 of that, we're going to get 4. And if I wanted index 2 of that, we're going to get 5. Okay? And these follow all the same slicing rules. So I could say I want from index 1 to the end. We're going to get 4 and 5. Or I could say I want from index 0 to the end in steps of 2. And we're going to get 3 and 5. So you can mix and match in any way that you'd like, which makes lists really, really powerful. So why the hell would you ever use this, I hear you ask? Well, this comes up quite a lot when you try to create tables in Python. So imagine if we had a list like this. We're gonna call it our table equals. We're gonna have a big list. Then inside there, we're gonna have 1, 2, 3 in its own list. We're gonna have 4, 5, 6 in its own list, and we're gonna have 7, 8, 9 in its own list. So let me just put some spaces in here so it's a bit easier to see what's going on. So we've got a list with 3 lists inside of it. Okay. Now, what happens if we type in our table of 0? What do you think that's going to give? If you guess it's going to give 1, 2, 3, you'd be right. And likewise, we can do our table 1 and our table of 2 to get the other lists inside there. So to select any one number, we need 2 coordinates, effectively, don't we? Say if I wanted the number 2, I'd have to type our table 0 and 1, right? To get the number 2. So what this means is the first coordinate, if you can imagine with me, the first coordinate is basically acting like the row, because if you imagine like a telephone directory, like, you know, the keys on your telephone, the first coordinate gets us the first row, or the row of it. So row 0 is 1, 2, 3, row 1 is 4, 5, 6, and row 2 is 7, 8, 9. And the second coordinate basically gives you the column. So if I have, this is column 0, column 1, column 2. Let's say if I wanted 6, right? That's going to be on row 1, column 2. So what I do is our table, row 1, column 2, and we get out 6. So what do you think, let's say 8. What do you think you'd have to do to get 8? If you guessed you have our table, row 2, because it starts at 0, 0, 1, 2, and then column 2, or column 1, 0, 1, you're going to get 8, okay? So you can see we've basically made a table with rows and columns. Now you can have lists inside of these other lists to make 3-dimensional cubes and so on, and go on for as long as you like. You probably won't ever need to, but it's possible. And hey, it might come in useful if you ever want to create a Rubik's Cube solving robot, or something that you want to keep a track of where all the colors are on the cube, for example. Now we can take slices of these smaller lists if we wanted to. So let's say I just wanted 5 and 6. Yeah, I go our table, it's going to be row 1, and I want from index 1 to the end, and we're going to get 5 and 6, and so on and so on. And it basically gives you a lot of control about what data you want, but it's more useful to think of these things just as tables. First you set the row, then you set the column, and you can use slices and things like that to pick specific data that you want. Okay, so I'll give you a break there, as we've covered quite a bit in this lecture, right? So let's just take a step back and digest it all before moving on to the next lecture. We first took a look at how to create lists. You saw how simple lists are to create, as all you needed was a set of square angle brackets, and just put the data inside with commas in between it. And after that, you learned that Python lists can hold multiple different data types at once, which makes them incredibly powerful, and we made a list that held strings, numbers, booleans, and lyrical genius all at the same time. You then learn how to access certain elements from a list by using the element index. Because lists are iterable data types, just like strings, accessing elements was the same as we've seen before when working with strings and slices. And yes, you can slice lists as well, and that works exactly the same. So finally, you learned how to create multi-dimensional data structures, like tables, by putting lists inside of lists, and then using several coordinates like rows and columns to access the elements. Now, while you won't be using these every day, it might come in handy, and you've got this lecture for reference, when you're building that Rubik's Cube solving robot that you've been dreaming about. So one thing to bear in mind is that slices don't actually modify the list in any way. That's just something to bear in mind. It just takes a copy of the data that you slice out. Now up next, we're going to move on to our next project, which is going to be creating Travis, the ridiculous security system. By building Travis, you're going to learn how to combine lists with logic that we learnt in the last section, and this is going to level up your Python skills so much that it's crazy. So I can't wait to show you, and I'll see you in the next video.